In this video, I will walk through a WPF application that uses MVVM with a delegating command in the view model. I have a link to the application on OneDrive. Feel free to download the zip file. Note that the address is case sensitive, and be sure to unblock the zip file by opening the properties window and click the unblock button before you extract the content. So I'm going to start by reviewing the application, then show you the architectural design, and finally do a quick code walkthrough. I want to mention that I followed here the MVVM pattern, and that means that I've decoupled the interaction between the user interface and the code behind. So this application is a simple calculator. 9 times 6 is 54. I have a clear button. All of these buttons here are associated with command delegation. So that's the focal point of the demo. So the first thing we're going to do is look at the class diagram. So as you can see from this overall layout, I've simplified the ability for somebody to be able to maintain this application. I have a view here on the left, I have a model on the right, I have a view model in the middle, and I have a delegating command that's associated with the view model. So the view itself is responsible for presenting information on the screen. That's simple enough. The model is typically responsible for managing application data and underlying state. In this case, it's going to represent our calculator. The view model is the intermediary between the model and the view, and it's going to wrap the model and also expose properties that implement change notification through this iNotify property changed interface. For command delegation, I use a class that implements iCommand and forwards all execute commands back to the view model. So that is referred to as command delegation, which is one of many approaches that I could have used in this application, but this one here is the most reusable. Also, my view model exposes several iCommand properties, multiply command, divide command, and so forth, to enable data binding. So my VM is behaving as what is known as a command invoker. Now let's take a look at the underlying code, so we'll do a code walkthrough. We'll start with the XAML, my calculator view. Very simple, I have a content control, and the content control retrieves the content through code behind. I could also have set the binding in XAML, but I prefer the code behind. So let's take a look at where I set this up. I set the data context here to an instance of my calculator view model, and we're also going to look at the template that I've used for my calculator in app.xaml. So here I set the data type of the template to the view model. And this is all you need to do to make the association with the view model type. Notice that this is not, the data type is not set to the calculator model, it's set to the view model. And from here it's very straightforward. All of the buttons have a corresponding command that ties into, through binding, an association with a property that I've exposed of type iCommand. And they're all the same. Okay, so let's now take a look at the delegating command. So the purpose of the delegating command, again, is to forward commands back to the view model. In my opinion, the most reusable solution. So the delegating command implements the iCommand interface. First thing I do is hold on to the backing fields that represent the delegates, one of type action and the other of type func, both provided by .NET. My constructor saves the arguments to backing fields. I now have my implementation of can execute and execute. So the can execute is going to be called by WPF when it receives a command manager requery suggested event, when it raises that event. And the execute is the invocation of the delegated command to perform the operation, for example, add, subtract, multiply, divide, or clear. And lastly, here we have our event handler, can execute changed. This can be useful if you're writing code that needs to explicitly tell WPF that something has changed in the UI. Maybe you're writing a background task, for example. The last thing we want to look at is the view model. And the calculator view model implements iNotify property changed. Holds on to the backing, or wraps the model as a backing field. And inside of the constructor, I create an instance of the calculator model. As I mentioned before, the iCommand property is going to provide specific implementation for each action. So we'll have, for example, one particular method that gets called for add, another for divide, and so forth. And the delegate is going to forward these methods back to this view model. So let's start by looking at one. They're all the same, actually, except they're different methods that are associated with the commands. So let's look at our clear command, for example. So the clear command is associated with a property of type iCommand, and it is going to create an instance of a delegating command, passing in the address of a method called clear. And I separated out the methods, by the way, instead of not writing the code in line to make it clearer to you as a user. So this delegating command is then going to take the method here that performs the clear operation whenever execute is going to be called, and it ties into the underlying model and calls its clear method. My next step is to raise the notify property changed event. And you can see that clear and add command are almost the same. The only difference being that instead of calling clear here, I called a method, or I pass in the address of add. So the add method calls back into the model's add method and then raises notify property changed. Subtract, the same thing. Return a new instance of a delegating command, pass in the address of subtract. So the execute method is going to call the model subtract and then raise notify property changed. So again, that's the gist of working with the command delegation pattern with MVVM. And let me just, as a reminder, there's the address of the application. Feel free to download at your leisure. Thank you for your time.